Spin My Cloud YouTube channel. Today we'll be discussing about AWS Lambda. AWS Lambda, if it is not configured correctly or if you have not used all the required settings, there are very high chances for a spike in your AWS expenditure. So we have to enable concurrency setting to avoid sudden spike in cost, especially in lower environment where you are doing some testing in the dev environment and you do not want Lambda to scale up too much and which results in the spike in your AWS expenditure. So I'll explain how the concurrency setting helps to minimize the sudden spike and end up having a surprise in the AWS bill. But before we go to that concurrency or the concurrency setting, we'll go by the terms. We'll start with what is Lambda concurrency. So what I'm talking about Lambda concurrency, you can focus on this part. So you can see at a given time, in this example, I have two Lambda functions mentioned here. At T1, I see there are invocation for this Lambda function 1 and 2. And Lambda function 1 is concurrently invoked 5 times in this case, and then the second one is at 6 concurrent execution. After some time, at T3 time, the Lambda 1 was invoked 3 times, and the Lambda 2 was invoked 4 invocations. So at a given time, the Lambda is triggered multiple times, and we will see how Lambda behaves at the behind the scenes for this kind of invocation. So when the Lambda is invoked, what it does is, behind the scene, you can it provisions a execution environment for each of the invocation at a given time. For this example, at T1, there was simultaneous invocation happened, and we have 9 invocation for this Lambda function 2, and since it's all at the same time, Lambda tries to run this concurrently. So you would have 9 execution environment provision for this, and to process the incoming invocation for this particular Lambda function. And a Lambda provisions this execution environment with the required programming environment that you have mentioned. Plus, it also downloads the code that you wanted to execute, and then it starts the environment. So it goes from the cold state, and then the Lambda gets initialized, and then it starts working or starts to run the code that needs to be done when there is an invocation. But it keeps on adding execution environment if there is a concurrent execution. Otherwise, if you get an invocation after few seconds of the current one is completion, it would use existing, or it would use the pre-provisioned execution environment to process the request. So that's what happens when Lambda is triggered behind the scene. When the Lambda is invoked behind the scene, it provisions the execution environment. So now, if you see 9 invocation, so what happens? You have if there is a concurrent invocation of 100. You are concurrently calling this Lambda 100 times. So Lambda does provision 100 execution environment to process those incoming requests, which is at the same time it was invoked. So how many Lambda can create like this? So if you by mistake or legitimate your business case tries to call the Lambda function for a 10,000 time, do you think the Lambda function would behind the scene provision 10,000 execution environment? No. So the Lambda have in each of the AWS account, in each of your AWS account, and for each region within your account, there is a soft limit of 1,000 in 1,000 concurrency limit, which means your Lambda function that you have in your account in that particular region shares that concurrency limit. So, for example, you have function, lot of functions like this, and all this shares the same concurrency pool or limit. So if one of the Lambda function, say function 3, is tries to invoke, for example, around 500 it has a 500 parallel invocation. It tries to consume from this pool, and the remaining 500 would all be utilized by the other one. So it's kind of shared pool of concurrency, and it would be shared by this functions, Lambda functions in that region. So it is a region level soft limit, and you would not have that kind of, even this 1,000 concurrency would not be shared by the another region Lambda function that is in your account. So understanding of concurrent execution, and we also know what happens when the concurrent invocation of Lambda behind the scene, it provisions the execution environment, and we also have an understanding of 1,000 soft concurrency limit. But now let's look at how the Lambda pricing is calculated to understand about the settings that needs to be changed. So Lambda mainly have two cost levers. One is the compute cost, the other one is the log ingestion cost. So we'll first look at the compute cost. How it is calculated is, for example, you have 3 invocation, and the invocation is lasting from T1 to T3 or midway to T3, and there are 3 concurrent invocations. And for this Lambda function, you would have specified the memory that you wanted for the function to run. Lambda determines, based on that memory, it determines the CPU, and it provisions your execution environment that we discussed here. The execution environment that Lambda provisions is based on the memory that you specify, and it determines the CPU, and accordingly it provisions that execution environment for us. So back to this here, so we have 3 invocation, and which means 3 execution environment would have been provisioned for the memory and the CPU specifications, and the Lambda calculation goes like this. So the total execution time is calculated like number of requests for the Lambda invocation, number of times the Lambda is invoked, multiplied by the duration of each execution. So in this example, it is, say for example, it is 2 minutes for each execution, or the execution for this one is 2 minutes, which means 2 minutes time 3 times the Lambda is executed. So that's the total execution time that would be used as an input for arriving the compute cost. The compute cost, it uses the total execution time into it also checks the memory that is allocated for your Lambda. So based on that, the compute cost is arrived. And then this is one part of the calculation. The other one is the log ingestion that is pushed to the CloudWatch log. So it is a separate from Lambda, but still this Lambda is introducing or inducing that charge. So I thought I'll also add it here. So the log ingestion to the CloudWatch log, the rate at which the log is pushed, plus the log storage, the storage of that particular log cost. So what happens, like, if there is a sudden spike of execution in your lower environment, which is unintentional, that you don't want to have a spike, you don't want to have a scale. So if your lambda is spiking, when I say spiking, it tries to scale up too much, like concurrent 500 execution, concurrently it tries to execute 700. So the compute cost would increase because the total execution time would be 700 times in that particular point. So into the memory that you use for your lambda. And what also happens is, when the lambda is invoked, we know that the execution environment gets created. For each execution environment, there will be a log stream created in the CloudWatch logs. So that through that the log is ingested. So which means you would have at that point, for example, 700 execution happened, which means 700 log stream would have got created and the log would have been started pushing there. So the CloudWatch cost would also increase because the sudden ingestion rate increase in the log that we are pushing, and anyway we would keep that log in the for the retention period duration. So you would also have that cost. So if there is a sudden spike, unintentional spike in your lower environment, there are very high chances that we would end up having a lot of AWS expenditure on Lambda function. But I can give you an example. Let's say consider you have an S3 Lambda trigger. You are having a logic written. So when you load a file in this Lambda, you wanted a Lambda to scan or process that file and perform some action. And during that testing or your development of that environment, unintentionally there is a 10,000 file that is being loaded in this bucket at a given time. So what happens is, the event gets created and it gets queued up in the SQS queue, and the Lambda starts to process that request. So in lower environment, we don't want to have 10,000 file to be processed, but it was unintentional. But because you place the file, the Lambda starts to process the event that is started to accumulate in this queue. This happens behind the scenes, so it starts to scale quickly because we have not set any concurrency limit. So it tries to use the 1,000 concurrency limit in our account soft limit, and tries to scale, and then it tries to process those files, and which would immediately starts to accumulate the cost for the two angle that we discussed here, on the compute cost, and the log ingestion cost. It starts to accumulate very quickly. So we avoid this. So we would be we have to play or use the concurrency settings to limit this kind of spiking. But let's look at what we are looking at about concurrency. I said we have a concurrency limit of 1,000 in the in our AWS account. So you can see this in the graph here. The bottom you see the time scale, and on the y-axis you would see the concurrency. So we know 1,000 is the soft limit for the concurrency within AWS account in each region, and that would be used by all your Lambda function. So what we are going to do is, your lower environment Lambda function, you can you can use a concurrency setting called reserved concurrency to limit the scaling of how many concurrent execution that it can do. So we know when we set the concurrent execution, the number of execution environment that it gets created also be limited. So for example, here the Lambda 1, I've set the concurrency limit of a reserved concurrency limit of 200, which means if you get invocation of beyond 300, it can only provision the execution environment up to 200, and beyond that it will the subsequent requests would be processed by the pre-provisioned execution environment. So for example, let's say in the same example here, I have 10 concurrent execution, which means in my Lambda, this Lambda function, I set the concurrency limit of 9, but I'm getting a request for 10 concurrent invocation. So what happens is it quickly provisioned those 9 execution environment because I have reserved concurrency that I've set as 9. So it scales up until 9. For the 10th invocation, the 10th invocation would be queued up, and it will not be processed in a new execution environment, but it will be processed by the existing one, which can handle the request once it processes the previous one. So for in our example, we were saying 10,000 file that needs to be processed. So if I have set my Lambda reserved concurrency for the Lambda that is processing at, in our case, assume that Lambda 2 is the one which is processing the 10,000 file, and you have set the concurrency of 50. So which means Lambda would scale up to 50 execution environment and starts to process those 10,000 files, but it will get throttled. It will take since all the other remaining files events needs to be queued up and needs to be processed slowly. The execution time would be longer. You can see it started from here and it goes all the way up to T12. And this Lambda you have set the concurrent reserved concurrency of 50. So beyond 50, it is not able to provision the execution environment. It tries to process the subsequent files, or tries to process the remaining files using the same execution environment that it has. Since it takes longer duration, you could immediately look at it, get some alert, and then make some understanding that there is something going wrong in your lower environment testing, and you can take an action to kill that Lambda immediately. And here you would also see there's another Lambda that I've set as reserved concurrency as 200, which means in total the reserved concurrency for two Lambdas, Lambda 2 and Lambda 1, we have consumed 250, and it has a remaining 750 for all other Lambda functions that it can consume. So say for example, the Lambda 3 and Lambda 2 does the same functionality, and both gets the file, the 10,000 file, the Lambda 3 also receives it to process, and Lambda 2 also receives to process at the same time. You can see the Lambda 3, it has unreserved concurrency of 750. So you have not set any concurrency, which means it tries to use all the remaining concurrency in that account in that particular region, and it quickly spikes up, and it tries to process all those file between T1 and T3. It processed all the files, and you would have end up having the cost of compute and lock ingestion that happened because of this execution. But whereas in Lambda 2, by T3, T4, if you realize it, you would be able to quickly kill it. So, but it should not be a manual action. You should be able to trigger, create a CloudWatch alarm from CloudWatch alarm. So you can generate an event and then kill the Lambda and change the reserved concurrency setting to 0 to kill that Lambda automatically. So we should have that kind of automation in place. But just to give you the sense, the research concurrency, if you limit in the lower environment, it would help to avoid such sudden spike in the Lambda cost, which comes unintentional or by manual error in the lower environment. So I'm in my AWS account in one of the region, and I could in the service quota, AWS has applied a quota of 10 concurrency execution allowed for my Lambda function. But even though its default quota value is 1000, but it is applied as 10. So which means if I provision a Lambda function account, it can scale up to maximum only 10. So this could be, save the cost. Maybe this is not a production scale account, so for safety reason, it is set the applied quota level as 10. So if I have to change this, then I think I have to raise a request with AWS to apply a new quota level for this. But the concept is the same. So if I go to Lambda, if I go to a Lambda function, you can change. You can first see in the dashboard, you can see the total unreserved account concurrency and your full account concurrency. If I create a function, Lambda function here, I can play with my Lambda function concurrency. So if I go to configuration, this is one of the test function. If I go to configuration, I can edit the concurrency that would be used by this Lambda function. So you can change the value here, the concurrency value, reserved concurrency value for this Lambda function. So if you change it to 1 or 2, then this Lambda can only scale up to 2 and then execute the environment for us. So you can play with this, or you can use this setting wisely to reduce your AWS Lambda spike, cost spike in your lower environment. Thank you.